Upbeat, rhythmic intro music plays for a few seconds, then fades into the background as the host begins speaking.
All right, let's jump right in with a kinda weird question. How does a door talk to a database?
Yeah, I know what you're thinking. And no, we're not talking about your smart home setup. This is, well, it's a whole lot bigger than that.
What we're actually talking about is IBM Rational DOORS. Now, if you've ever been involved in a massive engineering project, I'm talking aerospace, automotive, that kind of stuff, you might have heard of it. It's this incredibly powerful system for managing requirements. So think of this as our own little architectural tour. We're going to see how this thing is built, right from the foundation.
But first, why do we even need something like doors? I mean, what's the problem it's trying to solve? Let's paint a picture. Okay, imagine you're building a new jet. You've got, I don't know, hundreds of thousands of requirements. This part has to connect to that part, which has to be tested this way, and all of it has to meet some super strict safety regulation. It's like a giant, tangled web. Trying to track all that with spreadsheets? No way. It's a nightmare. That is the exact challenge DOORS was built for. All right, every good building tour starts at the bottom, right? The foundation. And for DOORS, that ground floor, the absolute bedrock of the whole system, is its database. And look, this is way more than just a big box to dump data into. It's the beating heart of the entire project. Every requirement, every change, every link between requirements, who's allowed to touch what, it all lives right here. It is the one and only single source of truth, and that's absolutely crucial.
So how do we talk to this foundation? Well, we can use something called DXL, which we'll get more into later. But with it, you can ask the database some really basic, fundamental questions like, hey, what's your name? Or what version are you? It's like the first, most basic handshake you can have with a system. Okay, so we have our foundation. But a giant pile of data isn't very useful if you can't find anything, right? So let's head up from the ground floor and start walking the halls. This next layer is all about structure, the hierarchy. Yeah, you can really think of this as the blueprint of the building. The hallways, the floors, the wings, it's this careful organization that lets you zoom all the way from the 30,000-foot view of the entire project, right down to one specific little requirement without getting completely lost. And here's what that blueprint looks like. It's pretty logical, actually. You start with the whole database. Inside that, you have your projects. Think of them as different wings of the building. Then each project has folders, and inside those folders, you find the modules. And the modules. That's where the magic happens. That's where the requirements actually live. Okay, we've explored the hallways. Now it's time to open some doors and look inside the actual rooms. We're going inside the modules to see what they contain. So when you're inside a module, the basic building block of everything is called an object. It's the most granular thing there is. A single requirement, the landing gear must support 50 tons, that's an object. But so is a heading for a section. Even just a plain old paragraph of text is considered an object. And what's really cool is how much control you have over every single one of these objects. It's kind of like checking the lock on each room. You can use simple commands to ask, hey, can I read what's in here? Can I change it? Am I allowed to delete this thing? It's super granular. But an object isn't just a chunk of text. It has extra information attached to it, metadata. And these are called attributes. A great way to think about them is like sticky notes or labels you put on things inside the room. One label might say status approved. Another could be priority high or owner the mechanical team. And this is a game changer. This is what turns a simple sentence into a rich, structured piece of data that you can actually work with. You can suddenly ask questions like, show me all the high priority requirements that haven't been approved yet. That kind of tracking is just essential. Okay, so let's recap our tour. We've seen the foundation, we've walked the halls, we've peeked in the rooms. But what if you want to rearrange the furniture in all the rooms at once? Or automate locking all the doors? You need a master key. And in the world of DOORS, that master key is called DXL, the DOORS extension language. It's a scripting language, and with it, you can touch, control, and automate literally every single part of the architecture we've just walked through, from the very top of the database down to one little attribute on one little object. So remember that question from the very beginning? How does a door talk to a database? Well, here's your answer. DXL. That is the language it speaks. It's how you truly communicate. Whether you're doing something simple like generating a report or something super complex like a script that checks thousands of connections, it's all DXL.
And this is how that conversation actually works, step by step. You, the user, run a DXL script on your computer. That's the client. Your computer sends the instructions over to the main Doors server. The server is the workhorse. It goes into the database, finds the data, or makes the changes you asked for, and then it sends the results right back to you. It's a classic client-server model, super reliable.
And DXL isn't just trapped inside Doors. This is really powerful. This quote from the manual talks about a command that lets other programs tell Doors to run a script. So you could have, say, an automated test system that, when a test fails, automatically runs a DXL script to update the status of a requirement in Doors. It makes the whole system programmable and connectable. So when you step back and look at the whole picture, you realize the architecture of Doors isn't just some static blueprint. It's a dynamic, living system. It's built specifically for organization, for incredibly detailed control, and most importantly, for communication.
And that really leaves us with one final big idea to chew on. What happens when every single requirement in a massive project, every little detail, stops being just dead text on a page and becomes a live, programmable point of data you can interact with? The possibilities are pretty staggering. Thanks for joining me on the tour.